Good morning, good afternoon, good evening. I'm Doug Gourlay back again with the inestimable Fred Chu. And today we're going to go through something a little bit different than we did last time. So in our last session on the continuing enhancements to network operations maturity model and how we're, as an industry, improving the interaction between the NetOps environment and the rest of the world around us, what we did is we hosted a discussion with some of the folks who built the Cilium project. And we talked about how to integrate and build cloud native environments and a lot of the networking challenges associated with that. And as always, we said we'd be coming back to you with some code samples and some demonstrations and some neat things you can do in your networking environment. Now, what Fred and I are going to show today is how we can actually integrate the networking function into a containerized environment and talk through some of the benefits of doing that. Namely, we then can gain a very clear understanding of this incredibly dynamic and elastic and cloud native environment and correlate what's happening in it with what we're seeing on the network, building very coherent policies and controls, and most importantly, maintaining that high observability level that allows us to go back in time and say, what happened last Tuesday at 9 a.m.? And being able to have the answer to that because we've gathered the data and we've stored it in a structured model where we can then explore that data and use that for quick RTO, for accurate root cause analysis, for as a networking professional, being able to own it when it's the network's fault, but having a very, very strong data-driven defense when it's not, and being able to very clearly articulate what the root cause of a problem is. Sometimes we call that the mean time to innocence in the finger pointing blame game that often happens in troubleshooting critical operational issues. So Fred, what do you got to show us today? What's new and cool, and what's the latest awesomeness off your keyboard, IDE, VS Code operating environment on your laptop vagrant world? Did I throw enough buzzwords there? Did I miss one?
I think you got a good smattering of buzzwords there, yeah.
All buzzwords, check, bingo.
Take a drink. So what I'll show here is I've got a Kubernetes cluster running in my lab, and I wanted to kind of take you through some of the tools that we've got going on here from a network operator's perspective, right? So what we're doing is we're running a Kubernetes cluster, and on every single one of these Kubernetes nodes, we are running CloudEOS to serve as the routing platform for those nodes. So this is providing network connectivity between those different Kubernetes nodes in the cluster.
And this is the same EOS routing stack that runs some of the largest clouds in the world, the largest financials, the largest carriers.
Exactly. So the cool thing is it feels, it looks, it is exactly the same as the EOS that runs on an Arista switch.
So network operators, like, this is my jam. This is what I know. This isn't a custom build. This isn't weird. This is the same, like, bug compatible code.
Exactly.
Or feature compatible. Sorry, my bad.
But the other thing is that we've also tried to wrap things up so that they are still usable and consumable by the cloud platform team, right? So the person who is deploying Kubernetes and is working with YAML files and doing all that, they can work within their YAML file world. But at the same time, the network operator can use their tooling, their monitoring tools, CloudVision, whatever it might be, to monitor and configure things at a network level as well. So we're trying to give you the best of both worlds here.
So starting to serve two masters, right? Maintaining this core integrity of its high quality routing code, low vulnerabilities, easy to troubleshoot and maintain, familiar interface. But on the other side, if you're coming at this from a platform engineering, cloud ops, cloud native, DevOps point of view, this is activated through the tools you're familiar with and integrates into that environment as seamlessly as possible?
Exactly. You hit it on the head.
Okay.
So I just—
You coached me well.
So I'm going to kind of a little slow because I'm assuming most of our audience are probably network guys, and so some of this Kubernetes stuff might be less than familiar to them. So
well, you might need to go slow sometimes for the DevOps team because that weird networking BGP thing might be a little anathema there too. No offense.
Right. Yeah, it can go either way.
Truly.
So the first command I did is this kubectl get pods for a kube system. So just to break this down a little bit, kubectl is your main CLI command that you use to interact with Kubernetes. And I'm telling it to get all of the pods in my cluster. So this is just showing me the workloads I have running in my Kubernetes cluster, particularly in the namespace of kube system. So these are my system pods providing resources to the operational function of the Kubernetes system. And so when I do this, you can see that we're running a bunch of Cilium pods. So that's providing me with the network policy component of the solution. And then you can see we're running all these CloudEOS pods. And as I mentioned, we're running one of each of these on every single node in the cluster. So every node in the cluster has an instance of CloudEOS running.
And can you just explain for a little more on what Cilium is, just for me?
Yeah, so Cilium is what we call a CNI, a container network interface, and it provides primarily a means of providing security policy, and actually very fine-grained security policy within your cluster. So it's going to define this application can talk to this one over this port, or it can't. And then they
So
also have some
is
really
it like ACLs?
it's like
Or is it
ACLs
more
on
advanced than
steroids.
ACLs? Okay.
Yeah, it's more advanced. It's on so they're using a technology called BPF, Berkeley Packet Filter, or eBPF, extended Berkeley Packet Filter, which if you ever use TCP dump, it's actually the technology that underpins TCP dump. So
So it's
super
well
high performance.
utilized. Okay.
It's highly utilized and highly performant, well baked in, but it's a really interesting and cool way to be able to implement something like security policy at high performance and fine-grained policy definitions there.
I mean, I think as evidenced by the granularity that I can apply TCP dump, the filters within TCP dump to the packets that I'm capturing, I think that's yeah, you're spot on. That makes a lot of sense to me. Then if it's high performant with that level of granularity, it far exceeds most network-based ACL structures granularity of what you can apply it to.
Right, and from a Linux server perspective, just way better and more scalable than IP tables, which was never built for this kind of environment.
Which was better than IP chains.
Right.
To date myself again. As your elder, Fred.
Just by a year.
Just by a year.
So here again, I did it with the -O wide, which lets us see a little more detail as to how this is deployed. So you can see each of the nodes that I've got here in my cluster being called out, the IP addresses of those nodes being called out. So essentially, again, we're just illustrating that we're running CloudEOS on all of those different devices.
What are the numbers, the sort of 5-character string after a CloudEOS name?
So that's just a randomly generated identifier because we do want to be able to identify each of these CloudEOSs individually. So when I scheduled the job with Kubernetes, I said, hey, I'm going to give you this Kubernetes job. And actually, let me show you that. I'll show you the deployment file that we used in order to deploy this.
Sure.
So let's scroll down this YAML a bit.
God, that's daunting.
It's a little daunting, but I'll break it down. So we have, what we're using is called a daemon set. And the daemon set says is Kubernetes, deploy this in a way that it's going to put one on every single node, right? And so in doing that, each one of them have to have a unique identifier. So it will take the name, which we're calling it CloudEOS here. We'll take that name and then it will just append that kind of 5-character randomized string so that we have the initial piece of the name that's standardized and then the random piece so we can uniquely identify each one of those. Now, while I'm here, actually, I want to show you something that looks a little more conventional to the network folks is some config stuff, right? So this is standard CLI.
I know what this is.
Yeah, right? Like this is standard CLI stuff that we would punch into any old CLI of an Arista device. And so what we've done is enabled the network operators to provide kind of a template here where I can say, this is CLI stuff that I want to insert into every single one of those EOS boxes as they come up. So
and
by defining
under the exec commands, are you there describing the type of data that's state stream, telling it to avoid some of the platform specific stuff?
Yeah. So yeah, if you parse through this is running our Terminator agent, which is how we stream our telemetry. And as you correctly pointed out, since this isn't a hardware switch, we can exclude certain pieces of data that we don't necessarily need. So that's
that was a not so feeble attempt to show that I occasionally know what I'm talking about.
So essentially, my little snippet here is saying turn on Terminator, but don't send me any ASIC stuff. I'm going to just configure this username secret Arista just because it's my lab and I want to have that for easy access.
And if you want better ways to do it, we have another webinar we recorded on how to manage secrets in your network that is far superior to admin as your default password.
Yeah, this is just a lab example. And then we're also turning on GNMI because hey, we want to stream OpenConfig over GNMI as well. So we want to play nicely with different open source tools in addition to CloudVision.
Just because we sometimes have a broader audience on this, can you give a quick overview of what Terminator is, as opposed to like, I'm here to save you, get on the bike or whatever?
Yeah, so Terminator is essentially a process that we run on EOS that allows us to stream the entire state of the switch to a central database repository. In this case, it would be CloudVision. So CloudVision runs a time series database, and it can then ingest all of this data from all of the different switches that it's managing in real time through a streaming agent that we call Terminator.
I feel like there's a T-shirt coming out of my right hand, Fred, which has like, you know, Ken Duda wearing sunglasses. It says, "Come to me if you want to live." State stream data to a centralized time series database for.
I think that should be our giveaway for this
Totally. Come to
project.
me if you want to live. We can have fun with this.
But yeah, so I wanted to kind of highlight this just because I'm trying to still illustrate the fact that we've put this into that Kubernetes construct. So, you know, the Kubernetes operator can deploy things they're used to, the way they're used to, but we're still providing you with the regular CLI experience too for the network person who needs to insert things that they need for their operational simplicity when they're deploying this stuff.
So could these be done as configlets through CloudVision as well, by any chance?
Absolutely. So we can go from whatever tool that you're used to using or want to use to deploy this stuff. We can accommodate this.
Okay.
Yeah.
Awesome.
So that's just a quick look at some of the ways we deploy this. So what we do when we want to actually deploy something like this is you do a kubectl apply, and then it just automatically schedules this stuff and pushes it all out.
And does it apply it to a single instance, or does it do multiple instances across the environment or all? Or
so it goes to what they call the Kube API server. So the Kubernetes API server serves as kind of this gateway between what Kubernetes wants to do and what the user is trying to do, right? So as an administrator, I say, hey, Kubernetes API server, here's my new configuration state that I want to declare for the cluster. And then the API server will then interact with all the backend components and get everything to be the way that you've requested.
Okay, makes sense.
Yeah, and so actually, I mean, I think you've drawn this parallel before. There's actually a very nice parallel between what we do with sysdb and our agents in EOS and how Kubernetes works off of a central etcd database, and the Kubernetes API server is kind of like your CLI, or if you will.
etcd is very synonymous with sysdb. And then above that, there's a CLI abstraction that works through an API interface to, you know, manage all interactions through into that central state database repository.
Yep, exactly.
And so, we could just define that as that's what a modern distributed system should look like for critical infrastructure.
No need to reinvent the wheel. So once we've deployed this, so I have this already running on my cluster. As you saw in that config, we're streaming out our telemetry over to CloudVision. So what I have here on the other window is CloudVision, and you can see, you know, I've got all of my leaf switches, I've got my spine switches. So this is the same CloudVision I'm using to manage my data center network, and all of that stuff shows up just as you'd expect. But in addition, now I'm also getting all these Kubernetes nodes. So all the different Kubernetes nodes that we've deployed CloudEOS on are also showing up here in CloudVision, and I can drill in on one of these and take a look at, say, the routing table, right?
So CloudVision being a time series state database repository, you're getting the routing table at this point in time. You're getting, you know, all adjacencies seen at this point in time. You're getting the name and UUID and such at this point in time. So if something changes, either in the routing topology or in the sort of platform deployment, that is all coalesced and captured, so that if I want to do a look back and say, yeah, like it's the worst call I get, right? It's like, hey, last Tuesday at 2 a.m. my application freaked out, and you're like, it's Thursday.
Right.
You know, it's probably fixed itself by now, courtesy of the emergency change control therapeutic trip over the wire. So the problem went away. Now, how am I supposed to tell you what happened? And the idea being that having all of this state stored actually does give me, hopefully, right, full observability into my environment and the ability to authoritatively say, this is what happened, this is what changed, maybe, and here's who did it, and this is the result. So if you saw a application performance problem at this point in time, it's because these buffers were full, this link was saturated, this path was congested because somebody steered this other traffic away they shouldn't have, or whatever the root cause actually is.
Right, and having that view consistently across the whole network, right? So I can see it not only on the switches, but now I'm getting this all the way down to the actual compute node. which is where I really think this differentiates from a lot of the things you might be able to deploy today, is where I don't get this visibility all the way down to the compute node from a Kubernetes standpoint.
One thing that really jumps out to me when you say this is that by aggregating all of this, not only into one place, right, but we address the sort of temporal time issues of it as well, right?
Mm-hmm.
If I have 4 different systems on 4 different clocks, it's really hard to infer causality.
Mm-hmm.
If I have 4 discrete systems all going into the same data set, all clocked the same, it's much easier to identify what happened first, what the actual precipitating events were. Not so basically I can go for root cause, not symptoms, when I'm trying to troubleshoot something, or frankly just develop a run book for my ops team to be able to say, if I see this series of events happening, here's how we've historically fixed it, and know that it can be much more repeatable in distributed execution across my ops teams.
Yeah, and to your point about the time series, I mean, you can see an example here on the right. So this is actually just showing me historically every time the routing table is changed on that particular Kubernetes node, right? So I can see, hey, this route got removed on May 27th. So, you know, if somebody says, hey, I lost connectivity to that subnet on May 27th, I can go back and take a look at that. So yeah, that having this historical data is super useful when it's trying to root cause something that might have happened in the past.
Gosh, you know, I'm just envisioning like, okay, here's the next follow-up webinar. Sorry, Fred. We do this, by the way, dear audience, friends. You know, some people would refer to it in venture capital worlds as spontaneous incorporation, but with us, it's sort of like spontaneous IP generation. But you had the demo of like sitting in like a ServiceNow ticketing queue and being able to send a ticket over to CloudVision that indicates host where we felt there was a problem and time where the problem was realized or perceived at, and then gathering what widget things, blocks, paths, whatever changed around that in a reasonable window, and putting that back into the ticket, right? So being able to say, how do I quickly take a ticket and say, were there network weird things that happened, right? Flaps, changes, routes, move, you know, adds, move, changes, reflected in routing tables, reflected in forwarding tables, or reflected in drop counters or such, that happened around, to a particular host or around the ecosystem around supporting that host in this particular time window. It feels like there's a really interesting query there.
Yeah.
That if we can get that data, it really will help people tremendously accelerate, again, further root cause analysis, or just if you're the level 1 operator who's getting this like gigantic ticket queue filling up and you have to munch through it every day, like if I could, you know, pre-scrub triage a third or 2/3 of those and go, these have issues, these don't, like I know which tickets I can spend my time on really quickly then.
Yeah. Yeah, no, I think I mean, once you have the data, there's so many possibilities, right? Then the first kind of key is just getting that data stored somewhere.
And how to express that in a meaningful, valuable way that a human can understand and interpret while keeping machine readable format so I can actually automate on top of it.
Totally, totally.
By the way, that's where usually as an industry we break you, right? It's like, hey, look, here's all the data you want in a CLI you can't parse.
Right.
Or here's all the data you want in a time series path model that I can't read. Right. So you need both.
Yeah, you need to be able to consume it. So now just to kind of, again, make the network guy feel at home, I'm actually going to exec into one of these pods. So again, I'm using this kubectl command, and exec just says, I'm going to set up an executable session in there. And I'm picking out one of my CloudEOS pods. And I'm going to say, I want to run, actually, let me do this really quick. I'm going to say, I want to run a CLI session, right? And so when I do that, it basically pops me right into that container that's running CloudEOS. And now I'm on very familiar turf, right? So
like,
I can do a show run, I can do a show ver. So I see the
T, reload, power now, enter.
Exactly. Right? So
all
to
the
me,
dangerous commands.
all the things I grew up doing. So the nice thing to me here is I don't necessarily want to enact config changes through this process, right? This is kind of breaking the whole cloud native mechanism. But
infrastructure as code, this configuration should be an expression of some central code repository plus the ingestion of other external sources of truth to dynamically composite this configuration based on the current state.
Right.
Okay.
But as a troubleshooting tool, you know, again, for those of us who have CCNAs, CCIEs, whatever they are, you know, to be able to do a show IP route or to be able to do a show IP BGP neighbor is, you know, just so much more comfortable when I'm trying to fix a problem or at least troubleshoot a problem that's happening.
And to be clear, this gives the network operator, like you're indicating here, a familiar interface that under periods of stress, we regress to a norm, right?
Yep.
And we regress to our comfort zone. If my comfort zone is banging out CLI commands on an 80/24 CLI, and that helps me fix the problem faster, that's the right choice. Right. On the flip side, it's like if my problem is something I'm dealing with at scale, and the right choice is writing a Python or Golang program to manage hundreds of devices at once, that's also the right choice in that scenario. But the question I would then beg is, does this inadvertently give the network operator some level of platform access that for regulatory requirements or cybersecurity policies or even just span of control is better left avoided? Like, do I gain kernel level access to the Linux hosts because I have this level of exec capability?
No, not necessarily, because you know, again, and there's a whole another aspect to this. I didn't kind of go in here, but we have this role-based access control, right? So you can kind of define levels of access to these different resources, and we can lock that down as needed.
Okay, got it. That makes a lot of sense to me. But this lets the platform team do their thing.
Exactly.
This lets the network team do their thing. And only with explicit configuration could they potentially get their fingers in each other's pies.
Exactly. Yep.
Okay.
Yep.
I think that's an important thing just to kind of for everybody to just kind of internalize is like, I know one of the fears I've always had is like, hey, do I want somebody else injecting routes into the network and potentially like overlapping IP addresses or accidentally leaking some sort of giant summary route in that causes me all sorts of problems? No, I'd like to avoid that. And on the exact flip side, it's like, hey, do I want this network guy typing kill-9 on some random PID in my host? Probably not.
Right.
Okay, so like let's let people play their positions really well as a team and know what the playbooks look like. And you know, you usually don't swap out the quarterback and the kicker for each other.
Right. Right. Yeah. And so just to kind of cap this off, you can see I also have these OC Prom pods running here, and this is actually a open source tool we have on the Arista GitHub, which is a Prometheus open config exporter.
Oh,
And
that's
so,
cool.
yeah. So essentially, what this
Talk
will
me through
do.
that a little bit. We're still on the first screen.
So there's a Go binary or a Go repository there on the Arista OpenConfig repo, where we will plug into an OpenConfig compliant device, such as an EOS, and then we will export whatever data you choose to a Prometheus endpoint, right?
So is this over like GNMI, GNOI, state streaming over gRPC of the OpenConfig models back to Prometheus?
That's exactly what it is.
Did
Right?
you write this, Fred?
I did not write this.
Oh, okay.
I cannot
Just
claim
checking.
credit for this one.
Okay.
But
I
yeah,
wouldn't put it past you though. So.
it's a cool project.
Take the compliment, man. Take the compliment.
Maybe I'll rewrite it in Rust or something.
Oh.
But so yeah, so at the end of the day, it's kind of serving as this go-between that's going to, on the one hand, and
Is go-between an intended pun?
Well, I think this speaks to the composability thing that we've talked about a few times too, right? So in this environment, now I'm taking this CloudEOS pod that's running over here, I'm just tacking on another pod that's talking to this to take OpenConfig data out and shove it over to Prometheus. So this flexibility of being able to stitch together a tool chain that works for me, I think is super powerful. And I think something that will kind of grow and evolve as we start to embrace these tools.
I totally get it. Yeah, I mean, the idea that while our job as a vendor is to provide a system that should be easy to use, that should solve a lot of problems for clients, the larger environments and estates we operate in absolutely have a myriad of tools across a variety of disciplines. And our ability to create a systems architecture that not only solves a broad set of clearly defined problems for our clients, but also is able to integrate into the other systems and tool chains that they use as part of a composited tool chain, I think is what enables larger estates to maximize value and scale of repeatable design patterns applied to their infrastructure. And yeah, I totally see what you're saying here. And this is a good example of that. It's us using Prometheus in some circumstances in lieu of Arista or InfluxDB or whatever the customer's preference is. But being able to integrate in that is high value. And it says that your infrastructure decision and choice doesn't have to be predicated on a management system and vice versa.
Yeah, yeah, and again, maybe just to level set for folks who aren't familiar with Prometheus, you know, it's one of the more popular monitoring tools and time series databases out there for cloud native type deployments. So
I was trying to somehow indicate making a big fire. I don't know if I failed utterly, but there's this flame behind my head on the.
Here. Yeah, that little fire circle.
There you go.
Yeah, so basically I'm exporting, I only chose to export a couple of BGP pieces of information, but you know, here I could see the BGP prefixes that are installed. I can execute this query and, you know, not as pretty as CloudVision, but I get some similar data, right? So here, each of these different CloudEOS instances have 42 or 43 BGP prefixes installed on those particular nodes. And then
it wouldn't be hard to write a monitoring agent to then look at that, graph it, and if I see significant deviations, generate alerts, alarms.
Absolutely, yeah. So here's a graph that's being generated. You know, I can drill down to different times, but the number
looks really flat.
It's super flat because the number of BGP prefixes isn't changing much in this now.
Which is a good thing.
Which is a good thing, but yeah, you could imagine if we were firing things up and tearing things down, this number could fluctuate a lot more.
Well, yeah, I mean, if I was to roll an upgrade across a data center now, while you're showing this, and upgrade all my, you know, green or left leaves, and then upgrade all my blue or right leaves at the top of a rack, you know, upgrade all the evens, upgrade the odds, whatever your naming model is, you would see the number of BGP neighbors going down by half effectively during this period of upgrade. And then as the network devices restored themselves to service, you'd see all of these going back. Being able to do an aggregate count of neighbor sessions against my number of pods and host, I think would give me a very effective, have I returned to operations effectively? Now I have, now let me upgrade the other half and know that I'm not black holing particular workloads because of a overly aggressive upgrade window.
Yeah, I think the other kind of interesting thing is we're also trying to, again, meet with the platform team in the middle here, right?
Yeah.
So I have CloudVision for the network team, and I can get all this great data about the network and understand what's happening. But maybe I also want to allow the platform team to have a clue as to what's going on in the network, right? So if they're using Prometheus, which they likely are, to monitor all the rest of this Kubernetes stuff, right? So you look at all these other things that I'm pulling in related to Kubernetes.
A lot of detail.
Tons of stuff. But if they say, hey, I would still also like to query do I have the right number of routes installed on my nodes? Or, you know, I want to see if something's blipped on the network because I saw some weird thing happening. So it gives them the ability to do a little bit of self-service as far as querying data, understanding what's happening, and put it into their dashboards as they see fit and as they start building.
It might even eliminate, I mean, let's say a prayer here, might even eliminate the occasional, hey, it's the network's fault call by self-servicing that it was not the network's fault before the call was made.
Yeah. So I think there's another important kind of component here. Not only are we enabling you to take this data and put it into third-party devices or third-party databases and tools for you to be able to consume as a network person, but it also opens it up to everyone else being able to consume this as you see fit. Again, you have control over what you want to export here or not export here.
That makes a lot of sense to me, Fred. Are there any common, besides the BGP neighbor peering, is there any other common statistics that you would recommend people consider capturing into Prometheus to assist in this troubleshooting, this sort of multi-domain troubleshooting environment?
I mean, interface counters are always a nice thing to be able to see, just to see how much traffic's going in and out. Route related things such as the BGP, because we are interacting with the control plane of the network here, I think are probably the two major things that folks are going to export here. And then again, all of this also still kind of plays into what our partners at Cilium are doing, and they're exporting stuff into this dashboard too. So then you get the SecOps teams involved as well, and also able to leverage this data and see what's going on. So it really allows you to start pulling all these disparate pieces of data together into common frameworks.
Got it. That's really awesome, man. What else you got for us here? This is super valuable. I totally get it. I really like the sort of multi-domain intersection here between taking network data, putting it in multiple places, yet the two data representations should match up so that if I'm using CloudVision or I'm using CLI or I'm using Prometheus, I'm getting a common point of view.
Exactly, exactly. Yeah, I mean, that's pretty much what I wanted to cover. I think we're probably already running long anyway, as we usually are.
Like we do.
On this.
Hopefully it's entertaining enough and somebody would give me a thumbs up on, and you, a thumbs up on YouTube, if wherever we post these. One thing I guess I'll leave as kind of a closing comment, we've often talked about, as a company, bringing cloud principles to enterprise, right? And if we think like, let's break down what do we mean, and we go cloud principles to enterprise, right? Like it's a wonderfully awesome, powerful statement, cloud networking. And you go, well, what's that mean? Well, the first part of that journey was cloud architectures, right? And it's high radix, leaf spine, cloud architectures that have proven to be invaluable, right? It's allowed us to build a repeatable design pattern into the network. And with a repeatable design pattern, I can now apply automation to scale it. That design pattern is capable of dealing with high volume traffic, bursty traffic, elastically deployed workloads, high scale, low scale, multicast, unicast, right? So having a design pattern that addresses the broadest cross section of workloads possible means I can now have that same design pattern, Lego blocked, rinsed and repeated across my environment. Thus, my automation is valuable because my automation is affecting a large portion of my environment. I'm not constraining it to a single snowflake or something. So that was cool. What Fred's talked about here today is that next big chunk evolution, okay? And that's cloud operations. How do we take all the principles we've learned about building really, really large, high scale, highly reliable environments? What did the operations look like? And there's some fundamental shifts we've seen, right? Companies have moved from 5-minute SNMP polling averages to real-time state streaming, from I gather a couple INTEF statistics to I want every single counter on the device stored in time series, right? I want monolithic tools, so I need composable tool chains made up of best-of-breed offerings with open APIs and interfaces between them. And I think that shift is what we've really highlighted here today. This is an example of the intersection of networking technologies with composable services in highly dynamic and elastic platform environments, yet not making trade-offs. We shouldn't have to make a trade-off between building for reliability, building for quality, building for security, building for observability, and being able to support the new breed of applications and the complicated, elastic, and dynamic app environments that our networks are being asked and challenged to support on a daily basis now. And so that's what really excited me about what you showed here today, Fred, is this is a very clear example of a cloud-style operation being brought to a cloud-native application in a networked environment, solving a multi-domain administrative and observability and operational set of problems. So I'd take my hat off, but then my microphone would go flying. But this was super awesome, and I really appreciate it.
Cool. Yeah, I hope folks have found it useful and interesting. And as always, we're happy to field questions if anyone wants to follow up and learn more about what we're doing.
Yep. Our emails and Twitter handles and all are up on the slides, and we're totally happy to interact with anyone. And any comments, feedback, and such, feel free to send our way. We hope we can continue to do these in a way that you find useful, practical, pragmatic, or just inspiring and awesome, or a cure for insomnia. So thank you to everybody again for your time and attention, and look forward to chatting with you all again in the next couple of weeks. Thank you.
All right, great, thanks.